Okay, so yesterday we went over the two problems dealing with long division. We were dividing a polynomial by another polynomial, and we're going to do that again today. But we're going to start off with a special case of long division, which is called synthetic division. Now, you can only do synthetic division when the polynomial you are dividing by, in this case it's x minus 2, it must have an x to the first power and then a constant. That's all it can have. It has to be a binomial, which is two terms, an x to the first power, and a constant. Now, it works a whole lot better and a whole lot easier when the x to the first power has a coefficient of 1. If it's not 1, you can still do it, but there's a little bit of manipulation you have to do before you can begin the process. So right here, this first one, I've got x squared plus 4x plus 1 being divided by x minus 2. So the way we do synthetic division is we write down all the coefficients. So first, x squared has a coefficient of 1, 4x is a coefficient of 4, and then the constant 1. So we would write down 1, 4, 1. Now notice how the powers decreased uniformly from x to the second to x to the first to our constant. If there was any that were skipped, we would have to plug in a placeholder 0, but that's not the case in this one. Okay, and then the next thing that we do is we take the binomial that we are dividing by, x minus 2, and we solve it for x. So if I took x minus 2 and set it equal to 0, then that would give me x is equal to 2. So we put 2 up in this little box. Yes, you've done this before. Now, I'm not very good at talking through the steps when I do synthetic division. I don't know why. It's one of the things that if I start talking, I start messing it up. I can do it here to start with. We bring the first term down. It becomes a 1. Then we multiply. So 1 times 2 is 2. And then we combine. 4 and 2 is 6. And then we multiply. 6 and 2 is 12. And then we combine 13. Okay, this last term is our remainder of 13. So that means that 6 is my constant. 1 is my x to the first power term, just working backwards. So I've got 1x to the first plus 6 with a remainder of 13. And again, you don't have to put the 1 in front of the x. I'm just putting it so you can see where that coefficient went. And then just like yesterday, if it doesn't ask for a remainder, if it wants us to carry it all the way out, it would be 13 over x minus 2 is another way we could write that. Again, we take the remainder and we put it over the thing we were dividing by, which in this case was x minus 2. Okay, the next one, I've got 4x cubed minus 5x plus 2 divided by x minus a half. So we write the coefficients. So x to the third has a coefficient of 4. X to the second is not there. So we give it a coefficient of 0. X to the first is negative 5. And then our constant term is 2. And then up in the little box, we would put a positive 1/2 because, again, we solve when we get x equals a half. And we're going to bring the leading term down. 4 times a half is 2. 0 and 2 is 2. 2 times a half is 1. Negative 5 and 1 is negative 4. Negative 4 times a half is negative 2. 2 and negative 2 is 0. So this time I have no remainder. And again, this would be my constant term. X to the first term, x to the second term. So that's going to give me an answer of 4x squared plus 2x minus 4. And this time there is no remainder, so that's my final answer. Okay, here's the next one. We have three functions. Let f of x equal x to the fifth minus 1 g of x equals whatever, h of x equals whatever. Then it tells me to find the following function values by using synthetic division, and then check by using substitution. So I'm going to actually do this in the opposite order. I'm going to first find what f of -2 is. So what we would normally do is we would plug in -2 to x into the function f. That would give me -2 to the fifth, which is 2, 4, 8, 16. That would be -32. And then -32 minus 1 should get -33. So we expect when we plug in -2, we get a value of -33. But now we're going to do it differently. So the way we're going to do it is by using synthetic division to find that value. Sometimes this is actually valuable. The math is a lot quicker using synthetic. This example, it's not. Okay, but in the homework, you'll see somewhere it actually is a little bit easier to do using synthetic. So what we would do is the number that's getting plugged in is -2, because that's what we are evaluating the function at, is at -2. And then again, we would write our coefficients. So I have an x to the fifth. I have no x to the fourth, no x to the third, no x to the second, no x to the first. Then I have a constant of -1. And then we would just perform synthetic division just like normal. So you bring that term down, multiply, combine, multiply, combine, multiply, combine, multiply, combine, multiply, combine. Okay, so what happened when I actually used the synthetic division? Well, look what the remainder was, -33, which is what you would get if you plugged it in the way we're used to plugging in. So synthetic division can be used to find what a function evaluates to be, and the answer is always the remainder. So again, I told you in this example, that really didn't save us much time using synthetic. But what if I was trying to find h of, and let's just do an easy one. Let's do h of 2. Okay, well, look at how much plugging in you'd have to do. 2 to the fourth plus 2 to the third minus 2 squared. And I know that you all have calculators. You'd probably just plug it in and not care. Okay, but if you wanted to work that out, it's actually pretty easy to do that with synthetic. So I write down my coefficients. I bring down the first term. And so I'd expect if I plugged in a 2 to get 45. So again, we can just check that if we want to. 2 to the fourth, 2, 4, 8, 16 times 2 is 32. 32 plus 8 is 40. 40 minus 4 is 36. 36 plus 6 is 42, plus 3 is 45. So, and you can imagine if you get an even larger number here, 3 or 4, or especially something 13, that could get very difficult to do in your head this way, and this way it's a little bit simpler and easier to follow the math. So, just a cool property of synthetic division. Okay, this one tells me to determine whether the given binomial is a factor of the polynomial following it. If it is a factor, then go ahead and factor the polynomial completely. So we have x to the third plus 4x squared minus 17x minus 60. And we want to know, is x minus 4 a factor? So just to review, what does it mean for a number to be a factor? So like if I ask you, what are the factors of 10? We would ask ourselves, well, what things can we multiply together to get 10? Well, 1 and 10 and 2 and 5 would be factors. One of the properties of factors is, if I were to divide the number by a factor, so 10 divided by 1, 10 divided by 10, 10 divided by 2, 10 divided by 5, it will not have a remainder. The remainder will be 0 because it divides into it perfectly. So we want the same thing to happen here. To know if x minus 4 is a factor, then we want to know, is the remainder 0 or not? So we could again use synthetic division because it is a binomial to the first power. And we're going to see what the remainder gives us. So 1, 4, negative 17, negative 60. Okay, up in my box would be a 4. Remember, when it's written like this, we go ahead and solve it. X equals 4 to know what goes in our box. To do the synthetic division, I bring down the first term. 4, 8, 32, 15, 60, 0. Okay, so it turns out that x minus 4 is indeed a factor because it gave us a 0 remainder. So now it tells me if it is a factor, then I need to use, or I need to go ahead and factor that out completely. So again, when we think about factoring, think back to how that's normally done. If I had something like x squared minus 4, we would factor that to be a difference of perfect squares. Right? What two things multiply together to give me x squared minus 4? So I'm trying to write down what things multiply together to give me this. Okay, well, when you find a factor like x minus 4, then it makes our job a little bit easier. That means we know we can factor an x minus 4 out, and then what's left is what you got when you divided. So that would be a 1x squared plus an 8x plus 15. And now instead of having a x to the third power trying to be factored, I now have a binomial, x to the first, and then this quadratic. Now we can factor quadratics, leading coefficient 1, what multiplies to be 15, added or subtracted is 8. That would be 5 and 3. So I could write this, I know that second parenthesis factors to be x plus 5 times x plus 3. So the synthetic division helped me get started in factoring the entire thing out. Okay, so what exactly is a factor? Well, if you look back in the last problem, we found that x minus 4 was a factor. That means at 4, at positive 4, we have an x-intercept of the polynomial. The graph would cross the x-axis at that factor. So again, the x-intercept is also sometimes called a root. It's also sometimes called a 0. All those terms are used interchangeably. So here we want to know, is the given number a 0? Is it an x-intercept? Well, again, what happens at x-intercepts? We know the function evaluates to be 0. The y value would have to give us 0. So if I want to know if this function has a has an x-intercept at 3, we could just plug 3 in, or again, going with this chapter, this section, we're going to use synthetic division to see what we would get if we plugged in 3. Again, one of those cool features. The number up here in the box is 3. So I bring down the 2. 2 times 3 is 6. That's 1, 3, negative 1, negative 3. So when I performed my synthetic division, I found it to have a remainder of 0, which means that the function, if I plugged in 3, would evaluate to be 0. So that means 3 is indeed an x-intercept. So is 3 a root? Is it a 0? Yes, it is. Again.
Don't you plug in for y if you're finding x-intercepts?
Mm-hmm.
Did you just plug in for x, or did?
So I'm finding x-intercepts, I'm not finding y-intercept. So the x-intercept is at 3, or an x-intercept is at 3, which means the y value should evaluate to be 0.
Yeah, I thought we would have put 0 at the top of the thing, and then
Mm-hmm.
just gave us.
Yeah. Now, if you plug in 0, that means you're checking is the origin an x-intercept. Whatever number you're plugging in, you're checking is it an x-intercept or not. Okay, here's the next one. We want to use division to write each rational expression in the form quotient plus remainder over divisor. And it tells us to use synthetic division when possible.
Yes, and it was like killing babies or saving babies.
So here we're dividing c squared minus 3c minus 4 divided by c squared minus 4. Now, the way that is written currently, I could not use synthetic division to simplify that. But just looking, I think I can factor both the numerator and denominator, and they may have a common factor that I can cancel out, which would then allow me to use synthetic division. So, in the numerator, c squared minus 3c minus 4 would factor to be c minus 4 times c plus 1. Okay, this is not going to work. I'm wrong.
Just set that equal to 0 and get 2 as your answer? Whoa, I'm confused.
So I tried to factor the numerator and the denominator to see if there were any common factors that could factor out. Well, none of these would cancel, so this is not the right path to go. I was wrong there. Okay? If one of those would have factored, it would have worked very nicely. Now,
Bottom equal to 0?
I can't
No. Dang it, the side is already on.
I can't use synthetic unless this is an x to the second, or in this case, I'm sorry. I can't use synthetic because of this c to the second. If it was a c to the first power minus 4, then I could go ahead and use synthetic just like normal. But I can't do that here because it is a c squared. So the only way I can divide this is by using long division. So again, I want my first terms to cancel. So right here it's a c squared, and I want it to be a c squared. So what do I need to multiply c squared by to make it be c squared? 1. So then I distribute that out. 1 times c squared is c squared. 1 times negative 4 is negative 4. Now where would that stack? The negative 4 should be over here with the constant. And there is nothing that should go underneath the negative 3c because it has no like terms. Then remember, when you do division, we have to subtract these. So this becomes negative and this becomes positive. We change the sign of everything. That eliminates to 0. I'm left with negative 3c, and that is 0. So now, can I make c squared into negative 3c? No, I would have to decrease the power, which is not what we want to do. So I know I'm finished. So that means when I divided, I got an answer of 1, and then 3c was my remainder. So I'm going to go negative 3c divided by c squared minus 4. Because this time it tells me write the answer as the remainder over the divisor, which is what I've been doing on several of the problems already, getting us ready for that kind of problem. So that shouldn't be anything new. Okay, this tells me the height of a box containing an HP LaserJet 3 printer cartridge is 4 inches more than the width, and the length is 9 inches more than the width. If the volume of the box is 630 inches cubed, then what are the dimensions of the box? So again, we're trying to find volume of a cube. So we find volume by multiplying the length times the width times the height. Okay, well, in this, I don't know what the length is, the width is, or the height is, so I don't have numbers to plug in. But if I want to treat this like the polynomials I've been working with, I could work this problem if I could get everything, length, width, and height, to be a single variable. So let's look at what they tell us again. They tell us the height is 4 inches more than the width. So again, if I write that in symbols, the height is 4 more than the width, which would be the width plus 4. That also tells me the length is, so that would be length is equal 9 more than width, so that would be W plus 9. And then we're just going to let the width be the width. So now if I plug all of these in, you can see I only have a single variable W to deal with, which allows me to use this synthetic division, or to use everything I know about a polynomial to help me solve this problem. So when I plug in the volume is 630, so I'm going to plug that in here. 630 equals the length, which is W plus 9, times the width, which is W, times the height, which is W plus 4.
And it's factored in.
Now we're going to go ahead and distribute that out. So W times W is W squared. W times 9 is 9W. And then that needs to be multiplied by W plus 4. So I have to distribute again. W squared times W is W cubed. W squared times 4 is 4W. 9W times W is 9W squared. Oh, I messed this up, didn't I?
Wait, why didn't
That should be 4W squared. Is that what you were going to ask?
no,
Okay. Then what were you going to ask?
why didn't we multiply like the W and the beginning when we distributed W out to W plus 9? Why didn't we do that with W plus 4?
I could have multiplied in any order I wanted to, but I only use each term or each multiple one time. So when I distributed the W here, then the W is gone. If I'd have distributed the W here, then I can't do it here, just one time or the other. It doesn't matter the order.
You need a W after the 36.
Yes, I do. Thank you. So again, that should be 36W. Now combining like terms, 4W squared plus 9W squared is 13W squared. Again, this was equal to 630. So if I want to work this out, I'm going to move the 630 over and make it negative. So 0 equals W cubed plus 13W squared plus 36W minus 630. So now I want to know what W is. So what we can do is we can we could try to factor that by grouping, but that is not going to work. Okay, so that's kind of mean of them to throw this in right now. I need to find what value for W will give me a value of 0 in the end. So I could use synthetic division. Now, I do not know what number to put in my box for the synthetic division. So I'm going to have to guess. Is that the way they want me to do this? That's the way I would do it. This seems weird for them to throw this in at the end. Give me 1 second. Okay, so we don't know what to put in our box for the synthetic division, but we know whatever we put in, we have to get a 0 remainder. So it needs to be a perfect factor. So a way that we can kind of get some numbers to guess is we use this method where we multiply the leading coefficient, which is 1, by the constant term, which is 630. So 1 times 630 is 630. So then I want to know what multiplies to give me 630 exactly. Okay, we're going to list some of the factors. So 1 times 630 could work. 2 times 315 would work. 3 times 210 would work. I do not think 4 would work. It won't. 5 times 126, 6 times 105, 7 times 90, 8 shouldn't work. 9 times 70, 10 times 63. And then if we have to keep going, God, this is mean. If we have to keep going, then we will. But we want to guess some numbers that are factors. So I'm going to guess that the number is going to be something 1 through 10. I don't think it would be more than that. How do you know it's 5?
I plugged it
You plugged in 5 and it worked?
into a graphing calculator.
Huh.
I plugged in the whole thing,
Okay.
and it gave me a line.
Okay, so let's try 5, okay? Using synthetic division. So if I tried 5, 1, 13, 36, and negative 630, I would bring down the 1. 1 times 5 is 5, 18, that's 90, that's 1, 2, 6, 12, 60, 630. Okay, so 5 did work. And what was left was x squared plus 18x plus 126. So my answer could still come from here. But since 5 worked, let's see if 5 makes sense for the entire problem. So if I plug in 5 here, then that would give me a height of 9, a length of 14, and a width of 5. So I would do 9 times 14 times 5, and I get 630. Okay, so since 5 worked, then when we have to give the dimensions, because again, that's what the answer is asking us for, that would be a height of 9, a width of 14, a height of 9, a length of 14, and a width of 5 would be the answer they're looking for there. This question is probably not one you'll see on your test, because that is pretty difficult to do, and it would require a graphing calculator to do it super effectively. But this is good that we got to practice this skill of identifying possible zeros, because that's something we will be doing in the next 2 sections.